An RFID reader is positioned under a section of track and detects when a locomotive is passing over that stretch of track, then sends a signal on the home network which updates a node-red dashboard, which shows which train has passed over the section of track. Is it possible to scale this up to a larger track layout with more RFID readers? The goal of this project is to create a model railway display GUI similar to the one seen at the Otaru Railway Museum. For this, we'll add 4 Wiegand 12-volt RFID readers, together with a Wiegand 4-door RFID controller to the track layout. Straightforward to set up, positioned underneath the model railway baseboard, with one 12-volt DC power input, and output is one Ethernet cable connected to the back of a broadband modem. The 4-door access controller has sockets for connecting the RFID readers. Again, D0 is the green connection, D1, white connection, and each socket also provides a 12-volt power supply for each RFID reader. To begin with, the 4 RFID readers can be positioned at these 4 locations on the track layout. Once the 4 RFID readers have been connected to the controller and switched on, it starts detecting when trains pass over each reader. To make the next section easier to understand, I've numbered the RFID readers 1, 2, 3, 4 using the same socket numbers on the controller. So where the controller has labelled a socket door 1, the reader connected to this is number 1, door 2 is reader number 2, door 3, reader 3, and so on. Boot up the Raspberry Pi and we'll configure the new controller to the network. As we looked at in the Model Railway Project Part 5, we can check the current configuration of the controller with the Get Listener node. Then if needed, we can set the correct IP addresses required for the controller to publish RFID events on the home network so that the Raspberry Pi can receive it and push its node-red. So on the side of the new access controller is its 9-digit serial number. So we can inject the serial number into the Get Listener node to discover its current configuration. Okay, so it looks like we need to update the IP address to the one being used by the Raspberry Pi, as well as the listen address port number. That should be easy enough, as we just need to replace the controller serial number and the inject node that we configured from the test controller in the Model Railway Project Part 5. Okay, testing reader 1. Looking at the object returned by the controller, we can see the serial number of the controller. There's also a door number value which maps to the socket number the reader is connected to on the controller, and a card number which we've mapped to the locomotive's RFID tags. And there's also a timestamp which is out of date. So we can reset the controller timestamp in our config flow tab. Next, quickly test readers 2, 3, and 4, and we should expect to see corresponding door numbers returned in JSON object. The information from the JSON object tree lets us see which RFID reader has detected a train passing over it. This starts off with message.payload.status.event.door. We can add this information as a new value in our function nodes, and we'll assign it to a variable message.RFID number. And you can also remove the variable message.payload equals true, as we now have a better way of turning LEDs on and off. I think we can be confident the nodes we are using to set the message variables for train color and train name are working the way we want them to. So it's time to move these from the test flow to the config flow. And connect directly to the listen node. A quick recap of the current configuration. A new RFID detection event is received, and we extract some information such as which train has been detected and its location. This information is passed from the config flow to the track flow in the form of a message, Three message variables have been set: message.loco, message.color, and message.RFID number. And our final step is to update the train color and name dynamically using the node-red dashboard GUI. Drag in the switch node to the track flow and delete the current LED and template nodes. We can use the new variable assigned to RFID number to update the location of trains detected by the RFID readers in the network. One LED can be for the section of track with the RFID detector. It's possible to configure the LED node to accept an input color through the message.color parameter. So scroll to the bottom of the LED settings and tick this box. Add some lines of JavaScript code to the function node. This code changes the LED to message.color for 2 seconds, then changes it back to white. Add 5 more LED nodes and connect them to an inject node to set them to white on startup. Great, starting to look a bit more like a track layout. Next, configure the text node that'll display the name of the locomotive that's been detected. Selecting a node size 4x1 should be sufficient to display most of the locomotive names. Okay, great, ready for our next test. Test looks good, although ideally the locomotive name should also clear from the display after 2 seconds. This can be fixed by adding the message.loco variable to our function node. So that after 2 seconds, an instruction is sent to return the LED to white and clear the locomotive name from the display. It's also good to make regular backups of your work in Node-RED through the menu on the right-hand side. This step is particularly advisable before adding or removing LEDs from the dashboard, as sometimes changes don't work out and it may be necessary to revert to a previous version. Repeat the same steps for RFID LEDs 2, 3 and 4, and we'll hopefully be finished the model railway project. Ready to roll. Let's test.